So we'll be solving number 2 from chapter 5, hard questions. So number 2 tells us to refer to scenario. The scenario states, let the supply and demand curve for gallons of gasoline be the following. P equals 2Q and P equals 12 minus Q. Treat each question as independent of each other. So number 2 reads, what are the price elasticities for demand and supply at the equilibrium, respectively? Okay. So to solve this question, we're going to have to move away from our current understanding of elasticity, right? So we're going to have to look at the difference between what is called arc elasticity and price or point elasticity. So this is the form of elasticity that we're used to, that you already know, right? This is arc elasticity, or the elasticity between 2 points on the demand or supply curve, right? So you're very familiar with this formula, right? Elasticity of demand equal to the percent change in quantity demanded over the percent change in price. And we use the midpoint formula to find those two things, right? Simple enough, right? This is called arc price elasticity of demand. Now we just shorten that to price elasticity of demand, right? But just understand that this is the arc form of elasticity. Now, the problem that we have does not give us 2 points. You see, to use arc elasticity of demand, you need 2 points, right? A Q1, P1, Q2, P2. But we don't have that for this problem. This problem asks for the elasticity at the equilibrium, right? So being that we were given 1 point, we're going to be using what's called point elasticity, right? Now, what point elasticity is trying to measure is what an infinitesimal change in price, right? A very tiny change in price would cause to quantity. How would that change quantity, right? Well, if we can't use the arc elasticity form, that uses the midpoint formula, okay, what can we do? Well, what we can do is we can take advantage of an approximation. Now, for the rest of this, I'm going to specifically focus on price elasticity of demand, but an analogous argument can be made for price elasticity of supply. All right. So we're going to take advantage of this approximation here. Right. This is pretty well known in math and statistics. Right. So we're used to this percentage change formula, right? Percentage change in quantity demanded over percentage change in price. That can be approximated by the derivative of the log of quantity demanded with respect to the log of price, right? So essentially, the change, the triangle here, is replaced with these little d's, right? Which stands for derivative. So if you've taken calculus, you'll know what I'm talking about, right? And the percentages are replaced by the logs. Now, this is just an approximation, but when you're looking for infinitesimal changes, this approximation is almost exact. So it's a very, very good approximation for the problem we're trying to solve. Okay. So again, using calculus, and again, this is not a calculus class, so don't get too caught up in the details. This is just to show you how it's derived. So we have our derivative of the log of quantity demanded with respect to the log of price, right? So this is equal to this expression here. So derivative of, or you can say differential of QD over QD, and differential of P over P. This is essentially using the chain rule and some other rules in calculus to take derivatives. Again, don't focus too much on the details. You just know that that this is how you come to the final answer. All right. This is just use some algebra to clean up this expression, right? And we will see that this is equal to this. So what is m superscript d? So m superscript d is the slope of the indirect demand curve, right? So essentially, the derivative of QD, of the quantity demanded with respect to price, is equal to 1 over the slope of the indirect demand curve. Now, note, we should know that the demand curve is always downward sloping due to the law of demand. So this slope is always a negative number, right? We just drop the negative number because it doesn't add any information, right? We know that price elasticity demand is always negative. Okay. So I'm using this term indirect demand curve. What does that mean? Right. So you're familiar with the typical graph of supply and demand, right? Price is on the y-axis, quantity is on the x-axis, right? That's referred to as the indirect or inverse supply and demand curves, right? So if a function of p is equal to the quantity demanded, if that is the direct demand curve, then the inverse function of quantity demanded equal to price is the inverse or the indirect demand curve, right? So, in other words, this form of the equation, here P would be in the y-axis, here quantity would be in the x-axis. But over here, actually P would be on the x-axis and quantity demanded would be on the y-axis. But that's not how we graph supply and demand, right? However, if you look at the equation for price elasticity of demand, you'll notice that quantity demanded is in the numerator and price is in the denominator. And again, if you know from calculus, you'll know that that means that the dependent variable is up here and the independent variable is down here. So it is this elasticity is essentially calculated using the direct form of the demand curve. Okay, so with that information in mind, we're left with this equality here, right? Essentially, the derivative of quantity demanded with respect to price is equal to 1 over the slope of the indirect or inverse demand curve. Well, from algebra, we know that if m superscript d is the slope of the inverse function, then 1 over superscript d is the slope of the function, right? Of the direct. And so in this case, if m superscript d is the slope of the indirect demand curve, 1 over m superscript d is the slope of the direct demand curve, right? So from calculus, since we only deal with linear supply and demand curves, right, the derivative of quantity demanded with respect to price would just be the slope of the direct demand curve, which we already know is 1 over m superscript d. So that's where this equality comes from. So to wrap up, the formula we would use to solve the question of what's the elasticity, the price elasticity of demand at the equilibrium would be this formula here. All right, so 1 over the slope of the indirect demand curve times the equilibrium price, or whatever the price is of the point given, over the equilibrium quantity, or whatever the quantity demand is that corresponds to the price given that we're asked to solve, right? And again, this m superscript d comes from this equation, right? This is the demand curve, right? P equals B, which is the y-intercept, or the price intercept, if you want to call it, minus m superscript d. So the minus is the downward sloping ness of the demand curve. This is the slope, and then quantity demanded. And you can make a similar argument for the price elasticity of supply, the point price elasticity of supply. Same argument. Okay, so let's solve the question then. So we're given we are given supply curve and demand curve. So we want to find the price elasticity, the price elasticity of demand and supply at the equilibrium. So first we need the equilibrium, right? So we know how to solve that. We just take 2Q equal to 12 minus Q. So add Q to both sides. I'll give this 3Q equals 12. And from here, Q is equal to 4. So that will be the equilibrium quantity. That means that the equilibrium price is, and you can just put 4 in either one of these, and you should get that the equilibrium price is 8. All right, so if let ED be the elasticity of demand, right? So we know now that the formula for elasticity of demand is 1 over the slope of the indirect demand curve times P star over Q star, right? The question asks for the, or we can just keep this general, right? Any P and Q, whatever the corresponding, wherever the point is at. In this case, it's the equilibrium, right? All right, well, we can answer this, right? What's the slope of the demand curve? Well, the demand curve is 12 minus Q, right? So in front of the Q is the slope, which is 1. And the equilibrium price is 8. Equilibrium quantity is 4. So simplifying, multiplying, doing the algebra, we get that the answer is 2. And we'll do the same for elasticity of supply. 1 over ms times P over Q. Yeah. So the slope of the supply curve, so P equals 2Qs, so the number in front of the Q is a 2, so the slope is 2, times the equilibrium price, which is 8, over the equilibrium quantity, which is 4. So this will be equal to what? So we have 1 over 2 times 8 over 4, which is 2. And so this will be equal to 1. And so the answer should be B. Elasticity of demand is 2, and elasticity of supply is 1.